This is Vodcast 7.3. We're going to classify chemical reactions today. For those of you who don't like math, this might be your favorite Vodcast so far. We're going to talk about different types of chemical reactions, and I'm going to enlist my friends from YouTube, none of whom I know, of course, but I'm going to splice in some YouTube videos in this Vodcast to show you an example of each of the following reactions. The first one will be decomposition, and then a synthesis reaction, combustion. Those are always fun. Those are the big explosions. Then we're going to have single and double displacement, a neutralization reaction, and a dissociation. So I'll show you an example of each one with a YouTube video, and then we'll come back and we'll talk about them. The video that you just saw is a decomposition reaction. Here's the definition for a decomp reaction. A single compound, or AB, here's my single compound, is broken down to produce two or more simpler substances. So AB goes to A plus B. That's our general formula. In the reaction that you just saw, there's actually two decomposition reactions that are happening. You have your sugar right here. We dissolved it in water, so it's an AQ. When you have the addition of H2SO4, sulfuric acid, the sugar breaks down into pure solid carbon, which was the black stuff, and water vapor. You saw the steam coming off. At the same time that's happening, there's also another decomposition reaction. The sulfuric acid is breaking down into water vapor, gas, water, plus sulfur dioxide gas, plus oxygen gas as well. So you can see there's two different decomp reactions. Here we had sugar, one substance, being broken down into two substances, the carbon and the water, or you can have the sulfuric acid at the same time being broken down into three different substances. One thing being broken down into two or more is an example of a decomposition reaction. You can write either one of these two reactions in your big table, your data table sheet for 7.3 Vodcast.
A small piece of sodium metal is placed in a flask containing yellow chlorine gas. The flask also contains sand to prevent the heat which will be generated by the reaction from cracking the glass. Initially, no reaction is observed between the sodium and the chlorine. The reaction will be initiated by adding a drop of water to the sodium.
Synthesis reaction. A synthesis reaction is actually the opposite of a decomposition reaction, where atoms or simple molecules combine together to form something that's more complex as your product. So here we have A plus B forming something more complex. The reaction that you just saw, I could never do at school because it would be way too dangerous. He took solid sodium metal and he inserted into a flask of chlorine gas, that was the yellow stuff, in the presence of just one little drop of water that he added, created that bright light, and formed NaCl, which you know as table salt, solid. Now, we couldn't exactly see the table salt because he had to have sand in the glass, otherwise that big explosion would have broken his glass. So the salt, is actually sitting on top of the sand for that example. So you can write, this is your example for a synthesis reaction. on your data table. Combustion reaction. A combustion reaction is a violently exothermic reaction. That means it produces a lot of heat as your product, usually involved with oxygen to form oxides. So over here on our product side, we're going to have lots of energy released. I did that burning bubble demo for you, the methane bubbles, at the very beginning. It was our first day of school, but I'm not brave enough to do them on top of my head. So he didn't have any hair. I thought that one was kind of interesting. So you've seen this equation, or you've seen this reaction before. Here's the equation that goes with it. Combustion reactions always have O2 as a reactant. So you see it's on the left side of the arrow, oxygen. And it always takes your other reactant, either your A or your AB, and combines it with the oxygen. So in this case, we have methane gas bubbles, reacting with O2. We had to have a little spark in here, had to initiate the reaction. Anytime you have anything organic combusting, how do I know it's organic? Has a carbon in it. Anytime anything organic combusts or reacts with O2, you always produce the same products. It's always carbon dioxide gas and water vapor, or H2O gas.
In this next displacement, we are pouring colorless silver nitrate solution into a beaker containing a copper coil. We notice that as the silver nitrate solution touches the copper, the coil immediately darkens and thickens. Copper is reducing silver ions to silver. When we take a closer look, we can see the silver crystals on the surface of the copper. Now, after some time, we also notice that the solution has turned blue because copper ions are formed. Copper has been oxidized to blue Cu2+. As we shake the wire, we see the large amount of silver that has been displaced.
In a single displacement reaction, one element replaces another element in a compound that's in solution. What does that mean? This is typically a solid. This is typically an aqueous, or a solution. The A, in this case in our general formula, will take B and kick it out, so that B is now all by itself, and A bonds with C in your product. In the example that you saw, there was the copper wire, solid copper, and she curled it up and put it in the beaker of silver nitrate, aqueous. It was a solution, right? And what happened? The copper actually kicked out the silver, so you saw solid silver crystals being formed, and the copper bonded to the nitrogen. The copper bonded to the nitrogen, that's that aqueous, that was the blue solution that you saw in the end. So here's the equation that you can write down on your data table sheet for a single displacement reaction.
We're going to do a double replacement reaction with potassium chromate and silver nitrate. Here's my potassium chromate, and I see that when I add silver nitrate to it, I am forming a nice red precipitate. And the precipitate is silver chromate. It's a double replacement reaction.
Double displacement reactions. A double displacement reaction is very similar to a single displacement reaction, except now two things are trading places. Instead of one being kicked out, these guys are actually going to switch places. So you usually have two ionic compounds. This would be something ionic solution, this guy's an aqueous, this guy's an aqueous. You have two liquids that you mix together, and they both switch. So here's my A. It was bonded to my B. A is going to switch with C and bond to D. C is going to switch with A and bond with B. You have a double swap. The cations or the anions trade places. So here's my example. This is the equation that you can write in your sheet. This is the one that you just saw. She had potassium chromate solution, which was the yellow solution. This was the yellow stuff. And silver nitrate, this was clear. The yellow solution, the yellow liquid, and the clear liquid, when she mixed them together, formed this solid, this guy was kind of a reddish-brown color, silver chromate. How did that happen? Well, here's the silver, and here was the chromate. They did a double switch. The K ended up with the nitrate over here, potassium nitrate. The silver switched places with the potassium and bonded with the chromate. This formed a red, solid, what we call precipitate.
I'm going to do a neutralization reaction. On the left, I've got hydrochloric acid, and we're going to check this by checking the pH. And on the right, we've got sodium hydroxide. All right, so this is my acid and my base. And make sure that, there we go. Now, I've neutralized. I have balanced it. And what I do, we try to figure out what I have, and let's fast forward to tomorrow. And I notice that the liquid has evaporated, and I end up with a crystallized substance. Okay? And sure enough, I'm not going to taste it, but I will find out that it's water that evaporated, and I am left with salt, NaCl. So this reaction, the sodium grabs onto the chlorine, and we get sodium chloride, plus the hydrogen grabs onto the OH group, and we've got water. And if
in the neutralization reaction that you just saw, she mixed an acid. How do I know something's an acid? Starts with an H. In a solution with a base. How do I know something's a base? It has an OH in solution. A neutralization reaction is also a type of double displacement. How do we know that? Well, in a neutralization reaction, these guys also switch places. One of your products for a neutralization reaction is always water. H plus OH forms water. The other double displacement part of it would be the B bonding with the A, the base, and the acid part of it, your anion and your cation. So the example that you just saw was HCl, aqueous, and NaOH, aqueous. If you take the H and the OH out, here's my water, H2O. What's left? I had a sodium and a chlorine. Sodium chloride. She said she wasn't going to taste it, but she could have. It produced pure table salt and water. Here's another example that you didn't see. I'll show you a couple more. Here's how it happens again. How do I know this is an acid? H2SO4. How do I know this is a base? It has an OH. Here's my water, H plus the OH. What's left? The K bonds with the SO4. You get K2SO4. A few more examples for you. I made all of the acids in red, all of the bases in blue. How do I know these are acids again? H, 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 H. How do I know these are bases? OH, 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 OH. They always form water, that's pure neutralization. Acid plus base equals water plus some kind of a salt. This is any kind of ionic substance, sodium chloride, sodium sulfate, magnesium chloride, or lithium phosphate. Acid plus base yields a salt plus a water.
Sodium chloride crystals are held together by attractive forces between the positively charged sodium and negatively charged chloride ions. When a crystal of sodium chloride is placed into water, the hydrogen ends of polar water molecules attract the negatively charged chloride ions and gradually surround them. Likewise, the oxygen ends of water molecules are attracted to and surround the positively charged sodium ions. The hydrated ions drift away into the solution, allowing new water molecules to surround newly exposed ions. Gradually, the entire crystal dissociates into solution.
That short dissociation video that you just saw showed you exactly how table salt dissociates in water. Here you had table salt, NaCl, it was a solid. When you mix that with some liquid water, what happens? We talked about this back in the ion section when we had intermolecular forces. What happened was the water actually pulls apart the sodium and the chlorine, because if you remember, water, H2O, was slightly polar with its partial negative charges and partial positive charges. It actually pulls the sodium chloride, the table salt, apart. So what happens to any ionic compound? It dissolves or it dissociates in water. It breaks up into its ions with the proper positive and negative charges. This is what causes ionic compounds to conduct electricity. Because what do you need to conduct electricity? You need charged particles that are able to move. Here's 7 practice problems for you. It's called Name the Reaction Type. So list 1 through 7 over on the right side or down below this slide, and tell me what type of reaction each of these examples are. Are they synthesis, combustion, decomposition, single or double displacement? Are they neutralization? Are they dissociation? And we'll go over this tomorrow.